Assalamualaikum and hello everyone! Welcome to our video presentation for MAT183 Calculus 1. So today our group will be presenting on the topic Techniques of Differentiation. So before we begin, let us introduce our group member. So hi everyone, my name is Malda binti Muhammad Ishar.
Hello everyone, I'm Nur Shazwina.
Hi, my name is Nurali Shadania binti Muhammad Amin.
Here's what we will cover in this video. So, what is differentiation? Differentiation is the process of finding the derivative of a function. The derivative tells us how a function changes. In other words, it gives us the rate of change of one variable with respect to another. Here are 6 main techniques of differentiation. The first one is power rule. Bring the power down and subtract 1. Second, product rule. Used when multiplying functions. First times derivative of second plus second times derivative of first. The third one is quotient rule, used for division. Bottom times derivative of top minus top times derivative of bottom squared. Next one is chain rule, for function inside functions. Differentiate the outside then the inside. Next, implicit differentiation, used when y and rx are mixed. Differentiate normally but add dy over dx when doing what. And lastly is linear approximation. Use tangent lines to estimate values near a point. And that's it.
Let's move on to the next question where we were asked to find dy over dx for two given functions. Let's begin with part A. Given y equal to 3x squared times secant x plus 2. This function is the product of two expressions. The first is 3x squared, a polynomial. The second is secant x plus 2, a trigonometric function. To differentiate this, I use the product rule, which states d over dx times uv equal to u prime v plus uv prime. So, it is defined as u is equal to 3x squared, u prime which we differentiated is equal to 6x, v is secant x plus 2, v prime is, after we differentiate it, we got secant x plus 2 times tan x plus 2. This is due to the formula, after we differentiate secant, we got secant x times tan x. After that, we substitute it into product rule formula which is u prime v plus uv prime. So, the final answer we will get 6x times secant x plus 2 plus 3x squared times secant x plus 2 tan x plus 2. That is our final answer for question 2a. So let's look on question B. Given y equal to 4x plus 2 over cos x. This time we have a quotient, a function divided by another function. To solve this, I use the quotient rule which is d over dy times u over v equal to u prime v minus uv prime over v squared. This is a quotient because the numerator u equal to 4x plus 2 depends on x, the denominator v cos x also depends on x. Since both parts involve x, we cannot just differentiate the top and the bottom separately. So, I define u equal to 4x plus 2. After differentiate it, we got u prime equal to 4. V is cos x and we differentiate cos x become v prime equal to negative sin x. So after that, we substitute it into the quotient rule formula which is u prime v minus uv prime over v squared. We will get 4 times cos x minus 4x plus 2 times negative sin x over cos x squared. So we simplify it and we got 4 times cos x plus 4x plus 2 times sin x over cos square x. So we can leave our final answer like this because in most calculus problem, the answer is acceptable. That is our final answer and we move on to the next question.
Now, let's begin solving the problem using implicit differentiation. We are given an equation where both x and y are mixed together and we cannot spread y on one side. So, we will use the method of implicit differentiation to find the derivative of y with respect to x. So, our goal is to find dy over dx, which means the derivative of y with respect to x. Step number 1. Differentiate both sides. We start by differentiating both sides of the equation with respect to x. Since the right-hand side is 0, its derivative is simply 0. We will now focus on differentiating the left-hand side one term at a time. Step 2 is differentiate the first term. The first term is y times the natural logarithm of 3x. This is a product of two functions, y and log of 3x. So, we apply the product rule. The product rule says the derivative of the first function times the second plus the first function times the derivative of the second. So, we take the derivative of y, which is dy over dx, and multiply it by log of 3x. Then, we take y and multiply it by the derivative of log 3x. Derivative of the natural log of 3x is 1 over x. So this part becomes y over x plus log 3x times dy over dx. Step 3. Differentiate the second term. Next, we differentiate the second term, which is negative e to the power of 2x plus 1. We use the chain rule here. The derivative of e to any function is just e to the same function, multiplied by the derivative of the exponent. So, the derivative of e to the power of 2x plus 1 is 2 times e to the power of 2x plus 1. Since the original term is negative, we get negative 2 times e to the power of 2x plus 1. Step number 4 is differentiate the third term. Now we differentiate the third term, which is negative tangent of 4y. Again, we use the chain rule. The derivative of tangent of any function is secant squared of that function times the derivative of the inside. So the derivative of tangent of 4y is 4 times secant squared of 4y multiplied by dy over dx. Since it's negative, we get negative 4 secant squared of 4y times dy over dx. Step 5. Combine all the terms. Now, we combine all three differentiation parts. The first part, y over x plus log 3x times dy over dx minus 2 times e to the power of 2x plus 1 minus 4 secant squared of 4y times dy over dx. And this all equals 0. Step number 6. Rearranging and solving. Now, we group the terms that contain dy over dx on one side of the equation and the rest on the other side. We move y over x and the exponential term to the right hand side. So, we are left with log 3x times dy over dx minus 4 secant squared of 4y times dy over dx equals 2e to the power of 2x plus 1 minus y over x. Now, we factor out dy over dx from the left hand side. This gives us dy over dx multiplied by open bracket log 3x minus 4 secant squared of 4y close bracket equals the right hand side. Now, we divide both sides by the expression in brackets to solve for dy over dx. So, the final answer is dy over dx equals 2 times e to the power of 2x plus 1 minus y over x all divided by log 3x minus 4 secant squared of 4y. This is our final result using implicit differentiation.
Let's move on to the next question, which is question 4. There are actually 3 steps to tackle this question. Let's go through them one by one. For step 1, we need to understand the expressions. We are working with 2 tricky expressions. We'll approximate both x equals to 81 because 81 is the perfect power, so it's easy to work with. And we will apply the linear approximation formula, which is fx equals to fa plus f prime a times x minus a. For step 2, we need to differentiate the functions. Let's find the derivatives. For fx equals to x power of 1 over 4, f prime x equals to 1 over 4, x power of negative 3 over 4, at x equals to 81, f prime 81 equals to 1 over 4.81 power of 3 over 4, which equals to 1 over 180. So, approximate the fourth power of 80.99. f 80.99 equals to 3 plus 1 over 180 times negative 0.01, which equals to 3 minus 0.01 over 180. Now for gx equals to 2x power of negative 1 over 2, g prime x equals to negative x power of negative 3 over 2. At x equals to 81, g prime 81 equals to negative 81 with the power of negative 3 over 2, which equals to negative 1 over 729. So, g 80.99 equals to 2 over 9 plus negative 1 over 729 times negative 0.01 equals to 2 over 9 plus 0.01 over 729 equals to 0.222014. So for step 3, which is the last step, we need to estimate the full expression, which is the fourth root of 80.99 minus 2 over square root of 80.99 equals to 3 minus 0.000093 minus 0.222014, which equals to 2.777893. Then, we rounded the answer to 3 decimal places to get the final answer, which is 2.778.
For solving differentiation questions, I recommend to review all differentiation techniques, then practice more problems to build more confidence, and focus on tricky topics like implicit differentiation. In conclusion,
The questions covers key differentiation topics, which is basic rules, implicit differentiation, and linear approximation, which focus on both understanding and application.